We move to describe the results of the presented single-image super-resolution algorithm. We start with images of scanned text. The image shown here served for training. You may recognize this page as taken from Boyd's convex optimization book. Moving to another page in the book, we take this image that will serve as y-age and create ZL from it by some blur and a 3:1 decimation in each axis. Our goal is to recover y-age from this ZL. A bicubic interpolation gives this YL result, and the super-resolution algorithm leads to this one, which is clearly better. In demonstrating super-resolution results, text images make superb demos, since the jump from unreadable text to a readable one is always very impressive. Here is another image to magnify, and its content suggests a scale invariance property. Thus, we will train on this image when building DL and DH. This is the super-resolution result, and it doesn't tell you much beyond the fact that it is more than 3 dB better than bicubic. In order to appreciate the differences, we show a zoom in on the original, the bicubic, and the super-resolution result. As you can see, edges are sharper and less jaggy. Here is another portion of these three images, and here you can clearly see the aliasing effect in the bicubic result, which is cleaned very nicely in the super-resolution one. As always in such works, one has to compare the performance to other methods by using an agreed-upon corpus of images and tests, and presenting quantified results using PicSNR or other measures such as SSIM. This table presents such an experiment with a comparison to the bicubic and Young's method. As can be seen, on average, Young's method gives a nice improvement over the bicubic interpolation, and this is further strengthened by the method presented here with a half a dB jump. So how much is half a dB? Will we see differences in the resulting images? Let's try and see for ourselves. These are three portions from three scaled-up images obtained by Young's approach, and these are the corresponding portions from the presented algorithm. We show these back and forth, and you can easily see that there are much less artifacts on the edges and elsewhere with the later method. It is time to summarize. The single-image super-resolution is a challenging problem and one that has received a substantial attention in the image processing literature. We can suggest solving this problem using the SparseLand bio, and in fact, there are various ways of doing so. We presented the work by Yi Ma's students from Illinois with its lovely coupled dictionary idea. This method is quite successful, and yet it leaves much room for improvements. Many papers followed up this work in the past 6-7 years and came up with alternative and better results.